Right, okay, so what I want to look at with you now is the motor effect. Now what I'm going to go through why the motor effect exists. Okay, and the motor effect is when you put a wire that's carrying a current through a magnetic field, then the wire will move. Okay, anything that uses a motor, such as a helicopter rotor, a food processor, a remote control for a console, anything that uses a motor utilises the motor effect. So the word motor relates to movement. Okay, for example, the motor neurons in biology are related to movement. The motor cortex in the brain is related to body movement. When we investigate the motor effect and the movement of wires once it's carrying current in a magnetic field, there's a few key facts that we need to remember. You need to remember that conventional current flows from positive to negative. Don't get me started on conventional current, okay, and related to electron flow. That is what you need to know for your GCSE. In terms of magnetic field, the magnetic field moves from north to south. So, why, if we place a current carrying wire in a magnetic field, does it move? Now, you don't need to know why, however, this will aid your understanding. So, remember we talked about the right-hand grip rule, and the idea that if we have got something going like this here, then that means that the current is flowing in a clockwise direction. Okay, and the magnetic field is going in the clockwise direction rather, so the magnetic field forms concentric circles around a current carrying wire. We also know the fact that magnetic field moves from north to south. So if I place this current carrying wire in an already existing magnetic field, we have got both the magnetic field from the magnets and we have got this concentric circle pattern going on. Now, because we've got two arrows moving that way, the magnetic fields will be added to each other. Because these two magnetic field lines are moving against the magnetic field of the magnets, that will be subtracted. So we end up with magnetic field at the top, but no magnetic field at the bottom. So if you imagine this magnetic field being pulled up like a slingshot, what that would do, it would fire this downwards, and therefore your wire would be kicked downwards by the slingshot action. And that's how the motor effect works. You don't need to know it, you don't even need to know it at A level, but it may help you make sense of what's going on. So we need to be able to now predict the direction of movement, and that's where the GCSE basic science comes in. We use something called the left-hand rule, okay? So the thumb points upwards, that represents the force, okay? So that represents the movement or the direction that the wire moves in, and that is operating on the y-axis. The first finger represents field, and I've placed that 90 degrees to this, okay, and that represents the direction of the magnetic field. And the current, which is the finger pointing towards you, which again is 90 degrees perpendicular to the finger above, represents the current. So thumb represents motion. First finger represents field, and the second finger represents current. And you can use that notation in your exam. So let's have a look at an example to predict the direction that this wire moves in. Here, we've got a wire connected to a power supply, and we've got a magnetic field moving from north to south. So, the current flows around the circuit this way, because it's going from positive to negative. The magnetic field is travelling from north to south. For 1 mark in an exam, you may be asked, what direction does the wire move in? So, we've got current, which is flowing this way. We've got a current that's flowing out of the board, and we've got a magnetic field that's flowing that way. My thumb is pointing upwards, therefore the wire would kick upwards and it would jolt in an upwards fashion. If I wanted to reverse the direction of the movement, I could reverse the direction of the current, or I could reverse the polarity of the magnets. If I wanted to increase the size of the force, I could increase the size of the current, I could increase the magnetic field strength, or alternatively, I could increase the length of the wire. Thank you.